Welcome back. Okay, so in this video we will take up a lighter topic, easier topic. So we will talk about errors and accuracies. So this is going to be a simple topic. Okay, so error. What is an error, and how do we measure it? So if any quantity whose true value, say if I'm measuring a voltage whose true value is 100 volt, but my meter shows it to be 101 volt, then we can say that this 101 minus 100, this 1 is the error, 1 volt is the error, if this is true value and if this is what the meter shows. Okay. So we can define the error as true value minus measured or estimated value. Okay. So, and I mean often people also write it as measured value minus true value. Okay. So both definitions are used in practice, I mean depending on the situation. So you should not be stuck with the fact that no, say that this is the right definition, this is wrong definition, or this is right, this is wrong. It's not like that. In practice we use both the definitions depending on the situations. So either is okay, and if you do not bother about the sign, you can just put a mod. Okay, even a mod, you can just also use a mod of true value minus measured value. So all these definitions are used depending on the situation. Okay, but this error we will call as an absolute error. Okay, and we can also define what is called the relative error. What is relative error? This is absolute error divided by the true value. Okay, and if you want to express it in percentage, then you can multiply it with 100. So this is optional. Okay, so this is optional. You can either express it in percentage or in per unit. So this 100 multiplication with 100 is not required. So depending on the way you want to express it, you have to multiply it with 100 or not. Similarly, this can also be sometimes defined as the absolute error. Okay, now the absolute error is defined here above, which has multiple definitions, and again relative error has multiple definitions. So this is absolute error divided by the measured value. Okay, so this, and you can multiply it with 100 if you want to express it in percentage. Okay, now you can divide it either with the true value or with the measured value. Okay, in practice, if the meter or the method is not that bad, I mean true value should be close to the measured value. Okay, they should not be very different, They are generally close. Therefore, whether you are dividing by the true value or measured value, these two should come out to be same. Okay. So, depending on the situation, you can either use this definition or this definition. So, that depends on the situation. So, for example, as I was saying, if true voltage of in any circuit is say 10 volt, say 100 volt, and measured value is 101 volt, then relative error, which is the absolute error, means 1 volt. Okay, 1 volt is the absolute error. So, I am just considering the positive number, and then divide it. You can divide it either by 100 volt, which is approximately equal to 1 volt divided by 101 volt. So, these two numbers are same. So, this is absolute divided by the true value. So, this is true value and this is the measured value. Both are quite similar, but quite close. So, you can use either definition. If nothing is specified exactly what you should do, then you can use either definition and your result should be similar. Okay. Now, let us take some problems. So, question. The question is, suppose I have a circuit like this, where I have two resistances in series and I measure the voltage across these two resistances with 2 voltmeters. This is, call it voltmeter 1 and voltmeter 2. Okay. Now, voltmeter V1 reading is say 10 volt, and say we know that V1 is 1% accurate. Okay. V1 is known to be okay, which means that the value of the true value of the voltage can be 10 volt plus minus 1%. Okay, that means plus minus 0.1 volt. And V2 reading is say 5 volt, and V2 is known to be say 2% accurate. Okay, I should rather say inaccurate, because when I say 2% accurate, we actually mean it's 2% inaccurate, or the error can be 2%. Although we generally say 2% accurate, I mean in colloquial language we often say 2% accurate or 2% or 1% accurate, but we actually mean it is 1% inaccurate or 2% inaccurate. Okay. Now, the question is, so what is this voltage across the two resistance? V. So, we can estimate this as V1 plus V2, two voltages in series. So, that is 10 volt plus 5 volt. Okay. So, this is the estimated value of the total voltage V. Okay. And now we will ask what is the error, or say relative error, or say we will compute both absolute and relative error, okay, in the value of V. So, we can ask the same question often in different forms, so we can also say, so what is the absolute and relative, say, accuracy, maybe we can say, actually we mean inaccuracy, not accuracy, inaccuracy, although we normally say accuracy, we actually mean inaccuracy when talking about errors. So these terms you should be a bit careful, I mean not careful, I mean should be open minded about, okay. So you should not memorize these terms that error is this minus this by this, or accuracy is this this formula. It's not like that. So depending on the situation, from the wording you have to understand what is meant. And the best practice which I will suggest is, if you have any confusion, always ask. If somebody is saying, if somebody is selling you a meter saying this is 10% accurate, best thing you ask that seller that, do you actually mean it is 10% inaccurate? Or what is the definition of your inaccuracy? Do you mean that the true value minus the meter reading is always going to be within the 10% of the true value? So it's best if you ask whenever you have confusion. And in general, you have to apply your common sense. So that's why I was saying in my introductory video that this subject requires a lot of common sense. So from using common sense, you have to understand what is actually meant. And once again, if you have any doubt, ask. In our course as well, in our quizzes, if you have any doubt in any question, ask. Okay, so that's the best practice. Ask, question. Okay. So what is the, so now the question is, what is the absolute or relative error or inaccuracy in the measured value of V? Okay, so we said that V1 is 1% accurate. So the solution, V1 is 10 volt plus minus 1%. So this is what I have meant when I said that this is 1% accurate. So I have meant the true value of V1. So let me write it, V1 true is 10 volt plus minus 1%, which is same as 10 volt plus or minus 10 into 1 by 100, 10 volt. Okay, so this will be 10 plus minus 0.1 volt. So this can be either therefore 10.1 or it can be either 9.9. Similarly, V2 true, that this will be 5 volt plus minus 2%. Okay, so this will be how much? This will be 5 volt plus minus 2% of 5. So this will be 5 plus minus, this is 0.1 once again. Okay, and therefore V true, which is V1 plus V2, V is this total voltage, V1 is here, V2 is here. So V true will be V1 true plus V2 true, this will be 10 plus minus 1 plus 5 plus minus 1. So then this will be 15. Okay, so 15, and then I can have this as plus or minus, Independently I can have this as plus or minus. It may happen when this is plus, this is also plus. It may happen that when this is plus, this is minus. It may happen that when this is minus, this is plus, and similarly this is minus, this is minus. So all possibilities are there. And what is the worst case extreme possibility? Extreme possibility is that this will be 10 plus and this will be also 5 plus. So that will be 15 plus 0.1, 0.1, 0.2. And the other extreme possibility is 10 minus and 5 minus. So we can have both of them minus together. So this is another extreme possibility, 15 minus 0.2. So the worst case, this we also call the limiting case, is that V true is 15 plus minus 0.2. Therefore, we can estimate V as 15 volt with plus minus 2 volt uncertainty or error or inaccuracy, whatever you call, plus minus 2 volt error or uncertainty, or you call it inaccuracy. Okay, so absolute error is therefore 0.2 volt. Okay, ignoring the sign, this is 0.2 volt, and relative error this will be 0.2 volt. Now, so I am dividing it with 15. Here 15 means the estimated value or measured value, not the true value. Okay. So, in this we are using the definition that relative error is absolute error divided by the estimated value. Why? Why are we not using true value here? Because we do not know the true value. We cannot use that definition, because the true value can be anywhere between 15 plus 0.2 and 15 minus 0.2. That means the true value can be anywhere between 14.8 and 15.2. We do not know. So, we cannot use that definition. So, in this situation we definitely have to use this definition where the denominator is estimated value. So, then this will be, okay, let us multiply it with 100 and you can compute what this value is. Okay. This you can find the value with a calculator. I do not have a calculator right now. So, you can do it, homework. Okay. So, this is how to calculate the absolute and relative error in this situation. Now, let us consider how relative error is aggregated if when we take products of quantities. Okay. The topic title is relative error under product or division. Okay. So, consider a situation, a question. Say we have a resistance which is carrying some current I. We are measuring this current with an ammeter A, and this is I, and the voltage drop across it is V. We are measuring the voltage drop with a voltmeter V. For now, you can ignore whether the ammeter is measuring the current through this resistance alone, or it is actually measuring this current plus this current. Now, for simplicity, assume RV, voltmeter resistance, is very high compared to this resistance R. So this current is very small, you can ignore that for now, for this calculation. Now say the question is, given ammeter reading equals say 5 ampere, and the ammeter is known to be say 1% accurate. That means 1% inaccurate actually. So I will not write this in always. So and say this voltmeter is 2% accurate. 2% accurate. I actually mean inaccurate. I'm not writing it again and again. I think the meaning is now clear to you. 2% accurate, I mean, it's not a meter which is only 2% accurate. Who will buy that? But if we say it is only 2% inaccurate, it's meaningful. So this is actually 2% inaccurate, although we say that this is accurate. Okay. So given the ammeter reading 5 ampere and plus minus 1%, and voltmeter reading is equal to say 10 volt plus minus 2%, what is the value of the resistance? R is equal to what? So this is part A, and part B is power consumption is in this resistance is how much. So R, we know this is like voltmeter reading by ammeter reading. So this is voltmeter reading by ammeter reading. Okay, and the power is voltmeter reading multiplied by ammeter reading. Okay, so this resistance will be, voltmeter reading is 10, this is 5, so 10 by 5 is 10 by 5 is equal to 2 ohm, and in this case this will be how much? This is 10 into 5 watt, so this is 50 watt. Okay, so this is the estimated value of R, and this is the estimated value of power. Okay, this is not the true value of R, or this is not the true value of power, because both the voltmeter and ammeter has some error, uncertainty in their reading. So we do not know the true value. We only have an estimated value, measured value. Okay. Now the question is, how much is the, so how much is the error, absolute or relative, absolute or relative error in the measurement of R and power, resistance and power. So this is the question. Okay. So the solution, first say power, let's do for the power. Now true voltage is voltmeter reading, which is 10 volt, voltmeter reading is 10 volt plus minus 2%. So true voltage is 10 volt plus minus 2%. So this will be 10 plus minus 0.2. okay, plus minus 0.2 volt. Similarly, true current, this will be 5 ampere plus minus 1%, right? Yes, 5 ampere plus minus 1%. So this is 5 plus plus minus, so 1% of 5 means 5 by 100, so that is 0.05 ampere. Okay, so 2% of 10 is 0.2, and 5 1% is this. Check my calculation. If my calculation is wrong, you can correct it. Okay. So true current, true power will be how much? This multiplied by this, 10 plus minus 0.2, and then 5 plus minus 0.05. So volt multiplied by ampere, this will be watt. Okay. Now it is possible that when this error is positive for voltmeter, this error is also positive for ammeter. But it is also possible that when this error is positive for voltmeter, this error is negative for ammeter. Similarly, other possibilities are also possible that when this is minus, this error is plus. When this error is negative, this error is negative. All 4 possibilities can happen. Okay. So now this we can write as 10, so times 5 is 50, and then we can write this as 5 multiplied by 0.2, so plus minus 5 into 0.2, and then plus minus 10 into 0.05, 10 into 0.05, and then these two terms plus minus 0.2 and 0.05. Okay. Since these numbers are small, these are small numbers, and the product of two small number is going to be further small, so we will ignore this term. This is a very small number. Okay. So for ease of calculation, we can ignore this. Therefore, we can write this approximately equal to 50, and here plus minus this is 1, and here this will be 0.5 plus minus 0.5. Okay, ignoring this very small term. So now this, the worst case scenario will be when this and this plus occur together. Okay, and or this minus and this minus occur together. So the worst case scenario will be 50 plus minus 1.5. Okay, so the absolute error will be how much? It will be 1.5 watt. Okay, so we have a watt everywhere. Do not miss the unit, otherwise it's meaningless. Okay, and the relative error will be how much? So this will be this value, absolute error 1.5 divided by the estimated value. Now our estimated value will be how much? 50. Okay, because estimated value, estimated power is, So we have done it before. Estimated power is 50. Voltmeter reading times ammeter reading is 50 watt. So let's divide it by 50 and 100%. So this will come out to be, let's first okay, so this 2, so 3%. Okay, and just observe that the error in the voltmeter was 2% and error in the ammeter was 1%. If we sum these 2 and 1, 2 plus 1 is 3. Okay, so this is same as relative error in voltmeter plus relative error in ammeter. Okay, so relative error gets added. Relative error gets added during product or during multiplication. So we have multiplied voltage with current, and the relative error in the product is the sum of the individual relative errors, multiplication. So this is one rule you should know. So we can prove it in general. Okay, so if I have, so in general, if I have two quantities, say call them A1 and A2. Okay, so in general, if A1 and A2 are measured values, so these are measured values, and their errors, okay, their percentage error or relative error, and call them delta A1 and delta A2. So these two are the relative errors. So delta A1 is the relative error for A1, delta A2 is the relative error for A2. So these are the relative errors. Then it means the true values, so we can write the true values. So true value of A1 will be A1, okay, sorry, let me call this as absolute errors. Let me call this absolute errors. Okay, so then the true value of A1 will be A1 plus or minus delta A1. So this is the true value of the first quantity. Okay, let me make a table. So we will have two quantities. Quantity 1 and its measured value is A1, absolute error is delta A1, for quantity 2, so these quantities can be voltage and current, or both voltages or both currents or anything, two quantities in general. So this has a measured value of A2, and we know it has an absolute error of delta A2. Okay, and if so, then the relative errors we can write as, so the relative error here will be delta A1 by A1. Okay, so you can multiply it with percentage, with 100 and express it in percent, but let me express it in per unit. Okay, so that's easy, so I'm ignoring percent here, and for this will be this delta A2 by A2. So that is relative error. Now let's consider the product. So the product, that means quantity 1 so its measured or estimated value will be A1 plus and times A2. Okay. Now its true value will be, so let's write true value here. So the true value for this quantity will lie between, so A1 plus minus delta A1 multiplied by A2 plus minus delta A2. Okay, this is because the true value of quantity 1 is A1 plus minus delta A1, and for this is A2 plus minus delta A2. Okay, so this is the true value. Now we can write this as A1 A2, A1 times A2 plus minus, say, A1 times delta A2 plus minus A2 times delta A1 plus minus delta A1 delta A2. Now delta A1 should be a small number. This is an error should be small. Delta A2 also should be small. So let's ignore this term because this is a product of two small terms. So ignore this small value. Okay, so this is the true value. If this is the true value, which is A1 A2 plus minus A1 delta A2 plus minus A2 delta A1. Okay, now we can find the absolute error. So the absolute error, so this is the estimated value. So the absolute error is this. Okay, now the worst case, the extreme case will be when both these errors are positive together or negative together. Then we will have maximum error. So the worst case error, limiting error, will be limiting maximum error or absolute error is A1 delta A2 plus A2 delta A1. So what will be the relative error? Relative error will be this absolute value okay, so this quantity divided by the measured value, and this will come out to be, so here in the first term A1 and A1 will cancel, we will have delta A2 by A2, then plus in the second term we will have delta A2 and A2 will cancel, delta A1 by A1. So you see that the relative error in the product is the sum of the individual relative errors, this plus this. So this quantity plus this quantity is this quantity. So this is true in general. Okay. Now this is also true for division. Okay. So let's consider, so let's take another row. Let's take the division. Suppose we want to find the ratio of A1 and A2. So this is what we want to find. This is the estimated value of A1 by A2. What will be the true value of this ratio? It will be A1 plus minus delta A1 and A2 plus minus delta A2. Okay, and then this is the true value. Okay, so this is the true value. Now the true value, you can write this as A1 plus minus delta A1 multiplied by A2 minus plus delta A2. Here also the same thing, A2 plus minus delta A2 and A2 minus plus delta A2. So you are multiplying and dividing by the same quantity. Okay, so this will therefore become, now what we will have, so we will have here A1, then A1, A2 here, and then expand it. So what else we will have, delta plus minus delta A1 times A2 minus plus A1 times delta A2. Okay, so I request that you complete this yourself. Okay, you should not watch my derivation, you should complete it yourself, and so that once again the relative error will be sum of these two individual relative errors. Do it yourself, or I'll also do it here. Okay, and now ignoring the product of two small terms. Okay, so this is approximately equal to this, and then let's divide it by so we'll have A2 square. This is like A plus B and A minus B, which is A square minus B square. So we'll have A2 square, and then product of these two terms, which is small, so I'm ignoring that. So this is approximately equal to this, and then this will be equal to, so let's divide it with A2. So A2 square, so we'll have A1 by A2, the first term. Okay, 1 A2 will cancel. Then we'll have plus minus delta A1 by A2, and here we will have minus plus delta A2 by delta A2 by A2 square and A1. So this is the estimated quantity and this is the error. And now this error, say when delta A1 is positive, it's possible that then delta A2 is negative or positive. So all combinations of positive and negative between A1, delta A1 and delta A2 is possible. Okay, so the absolute error we can write, the maximum absolute error we can write, absolute error we'll write here. So that is this quantity, delta A1 by A2, and we will take the maximum worst case when say this is positive and this is also positive, and or this is negative and this is also negative. So the worst case scenario will be when these two are added together. Okay, so we will write it as, okay, so we will write it as delta A2 A1 divided by A2 square. So this is the absolute error. Now what will be the relative error? Relative error will be this divided by this. So let's write it, delta A1 by A2 plus delta A2 A1 by A2 square whole divided by this A1 by A2. Okay, this will come out to be, so the first term will be delta A1, so this divided by this divided by this, so delta A1 and then divided by A1, A2 will cancel, and the next term is this, where we have this delta A2, A1 will cancel, and 1 A2 and this A2 will cancel. So we will be left with only 1 A2. Okay, so here you see this is once again This is the relative error in A1, this is the relative error in A2. So for division also the relative error gets added. So the note the important result is that the relative error gets added in product or division. Okay, so it's added for both product and division. It's never think that it's subtracted. It's added by magnitude. Okay, but it's true only for the relative error. It is not true for the absolute error. Absolute error gets added for summation of quantities, as we have seen in the first example. In this example, the first example that we have dealt with here, there the absolute error gets added. Okay, but for product and division only relative error gets added. So this is an important result. Okay, so now let's finish the question that we have said. So what is the error in estimated R or power? So power we have already computed. The estimated relative error in power was 3%. Now for resistance in this question, okay, going back to the question, original question, so the resistance estimated value, it was here 2 ohm. Okay, voltage was 10 volt plus minus 2%, current was 5 ampere plus minus 1%. So estimated value of R was 2 ohm and relative error, you can compute it thoroughly, but now since we already have developed a formula, let's use the formula directly. Relative error in resistance in the estimated value of resistance it will be the sum of the relative error in voltage plus relative error in current. So this will be 2% plus 1% is equal to once again 3%. You could have done it thoroughly also, like the way that R is equal, R true is equal to 10 volt plus minus 2% is 0.2 volt divided by 5 ampere plus minus 1% is 0.05 ampere, and then you expand what this is, find the absolute error and find the relative error. You can complete it and finally you will see that the relative error comes out to be 3%. So I will be happy if you find the relative error with a thorough computation like this. So I put this as a homework once again. So thank you for watching.